In this video, we're going to look at the information that the periodic table contains. It has so many features and properties and characteristics that you can determine by looking at the placement of the elements. This screen is just for my students. In class, you guys have told me that you just look at the screen and see the words posted and you don't really listen to the words. But in this case, I know that I'm recording this with a limited amount of words on the screen. So you're going to want to summarize and write some of the information down into your notes. So here on this screen, we're going to look at the Bohr model, and we're going to look at how adding each new element and each new electron changes. You can see I've replicated the first row on the periodic table, lithium through neon, and I've represented the first column, or a part of it anyway, lithium through rubidium. And you can see the commonalities in the Bohr model across the first period, the first row, is that we are adding each successive electron into the ring. We're adding a new electron as we go across, and you continue to add them in that same ring. Now, going down a column, all of these elements in that column all end with one electron in its outer ring, and that's what causes them to have similar properties. So we're going to look at these two different placements and how they cause different properties for the elements in the periodic table. Let's talk a little bit more about working across a period. So this is a row on the periodic table, and you can see that they all have two energy levels represented. The first energy level has 2 electrons in it, and then the outer energy level is what's changing as we change elements. As we work our way across, we have 1 electron, 2, etc., the whole way up through 8. What happens is that each time that we do a different element, we're adding both a proton into the center and a new electron. And as we work our way across, the protons are in the same spot, but we're adding our electrons into the same energy level. Now this causes different properties to occur, and some of the properties, as we look across a period, you're going to see different characteristics as opposed to going down the row. So you need to realize that in a period placement, when we're looking at elements and comparing them across the row, that the new electrons have added to the same energy level, and that we have also added a proton into the center. In this look, we're looking at down a family or a group, and what's happening here is that you are adding your new electrons to a new energy level. You have 2 energy levels here, you have 3, this one is 4, and this one is 5. So each time that we're adding an electron that's different, we're adding a new ring. You still are putting your protons into the center, but you're adding your new electron further and further away from the nucleus. And that's going to have an effect on different characteristics and properties that we look at later on in this chapter as well. So you have 2 different features going on in the periodic table, because the periodic table, if you remember, is organized as a table this way, but there's also placement up and down that has similarities as well. So you can be looking at things going left to right, but you can also be looking at things top to bottom, and you're going to see a repetition in the characteristics. Now, when we were looking at the electron placement, we looked at this periodic table with a little more depth, and we've assigned it to some different features depending on if we were looking at electron configuration or quantum numbers. And you can see in this colorful periodic table here on the top of the screen that, the elements are placed into a specific spot depending on where their electrons are being added. Now, we've talked about why they decided to put these bottom 2 rows down here separate, and what really is just occurring, and we've talked about it briefly, is that when it expands like that, it just makes the table much larger. In fact, it would have to fit on a piece of paper. It would be very, very challenging. But you can see that this F section down here actually does fit onto in between the S and the D section, as we detailed in the electron configuration and orbital in the quantum number chapter as well. So why did Mendelev's table work in 1869 when he organized, and he was not the first, but he was probably the most, he was obviously the most detailed in his table. And when he was sorting his cards and putting his elements into order, this picture here is what he actually built. And it kind of looks like what we've got. You know, hydrogen is on the top, and if you want to think of it as going this way, which is not exactly what we're doing, but the thing that Mendeleev did is he looked at the properties, and some of the elements just did not fit where the next column should be. So he lined them up based on properties as opposed to just mass. And you see that in a couple places. Iodine is one of them, and tellurium. He kind of flip-flopped them backwards because they fit the properties, but their masses were not increasing. The other feature that Mendeleev had is that he left gaps where he could not represent an element that fit where it should. And he even took those pieces of information and he made predictions. He predicted with very good accuracy, he predicted what the elements were going to be that would fit to those spaces. And in fact, multiple of them went on to be discovered during his lifetime. And he was actually able to say, okay, well, see, this is what I was saying. So let's look at this periodic table that Mendeleev had, kind of rearranged into what we looked at. Our periodic table was sorted this way, and you can see these green areas are where Mendeleev knew that there were gaps. He had gaps here, and he predicted these elements. Also, at the time that he was doing his predictions, there were no lanthanides and actinides found at that point. So his periodic table, if you want to take the elements that he knew of and sort them into what the periodic table, our current modern version is, he first sorted it based on mass and properties, but it was not mass is the rule that you must follow. Mass could be rearranged in order to follow the properties. So the question begs then, how is the modern periodic table arranged? Well, since Mendeleev's time, we have gone on to find atomic number, and our periodic table is actually sorted by atomic number. The modern periodic law is based on that. But Mendeleev's periodic table in 1869 was based on properties and mass. So it is an enduring table that helps us understand a lot of features. And the rest of the unit that we're looking in, we are going to look at specific characteristics based on the placement in the periodic table.